Welcome to part 3 of this maze game tutorial for Android. Last time I showed you how to put the maze on the screen. But you can't really call this a maze yet, because all cells are still surrounded by 4 walls. So today I'm going to show you how to change that. I'm going to use an algorithm called recursive backtracker. First, you choose an arbitrary cell. I chose 0, 0. Make it the current cell and mark it as visited. Then you check if there are neighboring cells you haven't been yet. In this case, there are 2. So you choose one of them at random. This is the next cell. Now remove the wall between the current cell and the next cell. Make the next cell the new current cell and mark it as visited. For the backtracking, we also need to remember where we have been previously. So we put that position on a stack, which is a last in, first out memory. Now repeat the process until you get to a position where there are no unvisited neighbors. Then backtrack to a position where there is at least one unvisited neighbor and keep going from there. At the end, you backtrack to the first position and the stack is empty. Now we can put the algorithm in our create maze method. First, we need a stack for cell objects. And we also need 2 variables for the current position and the next position. After the initialization of the 2-dimensional array, set the current cell to the cell in the upper left corner. So cells 0, 0. The next step is to find the unvisited neighbors and choose one of them at random. Next, equals get neighbors or get neighbor from current. This get neighbor method doesn't exist yet, but I will implement it later. Now we have to check if we actually get a neighbor from this method. So if next is not null, remove the wall between the current cell and the next cell, which I will also implement later. Put the current cell on the stack with the push method. Make the next cell the new current cell and mark it as visited. This is done when we find a neighbor. When we don't find one, we have to backtrack. Else current equals stack.pop, which gives us the top element of the stack and also removes it from the stack. Now this would only take one step and remove one wall. So we have to repeat it until all cells have been visited. Do while, and instead of checking if all cells have been visited, we can also check if the stack is not empty. If it's not empty, we repeat the process. If it's empty, we're done. Oops, I forgot to mark the current cell at the beginning also as visited. Otherwise it could go from the start to the next cell and back to the start. I will implement all these red methods and attributes in the next video. Until then, sleep well.